Hello, everybody, and welcome back. And we are on Pset 3 Solutions. So, look at the image below, identify some of the following defects: vacancy, self-interstitial. These are all substitutional impurities. This looks like an edge defect. Again, the line doesn't continue to propagate, so edge defect here, edge defect here. What else? Edge defect here. This is a impurity interstitial. So we found this 0D, 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 bang, 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 0D, edge dislocation 1D, bang, grain boundary. Not really here. So no grain boundary, even though that's 2D, 3D. Frankel and Shockey pair are 0D, but we don't have an ionic crystal. So there you go. That's number one. All right. Write the Frankel and Shockey defect reactions for PbO3. The enthalpy of formation of Shockey defect is 0.1 eV. Frankel is which one will be dominant. The dominant reaction is always going to be the one with the lower enthalpy of formation. So the Shockey defect will be dominant here. So let's go ahead. Frankel and Shockey defects. So null for Shockey goes to vacancy plus vacancy of Pb. Pb is 3 plus, so 1, 2, 3. Vacancy of oxygen, 2 plus, so I'm going to have to do 2, 3, and then I'm good to go. For the Pb, X, vacancy in Pb is 1, 2, 3, plus Pb interstitial, which is 1, 2, 3. Oxygen X, oxygen goes to vacancy in oxygen 1, 2, plus oxygen interstitial. There you go. Got it. All right. Let's write three defect reactions for the incorporation of NCl3 into, so NCl3 into PCl5. And one must include an anion vacancy, so vacancy in Cl, so that's 1. So Cl minus to 0, so that's going to give me a +1 there. So another one has to be NCl3-PCl5. Cation interstitial. So again, we need to have an N in an interstitial site. You could also have a self-interstitial, but you would probably want to do that. And that's going to be 1, 2, 3, and then NCl3 to PCl5, because it's into that one. Substitutional cation. So N, where P should be, so it's 5 to 3, so that should be -2. All right, let's get to work. So I am going to also add, to counteract this, because we need to have N in there. Actually, let's go ahead and do this. So once I have N here, I'm going to do a vacancy of potassium, because P here, or phosphorus, excuse me. Yeah, I believe so. Yeah, P is phosphorus. So I'm going to go to, this is going to be -5, 1, 2, 3, 4, 5. So now I can do, to have charge neutrality, I can have, let's see, I need 5 of these, and I need 3 of these. So if I do 5 here, that's going to give me 15 ClClX, and I need 3 of these. We're good to go. That's balanced. Here, I could do a vacancy in my Cl, for example, in my anion, and I can do this one here. I can do 2. Now I'm balanced there. So now what do I need? I just need plus I need 3 ClClX, N, Cl, good, P, Cl5, good to go. So I can do, plus I can do here, let's do something different. I always like to kind of switch it up a little bit. What if we also had, well, let's do plus an N interstitial, so that's going to be 1, 2, 3, plus, let's do a vacancy now in P, So I have 3 here, 4, 1, 2, 3, 4, 5. So I can do 2, right? And then I could do plus 3Cl, ClX. So I have 5 here, negative, 3, 2. That works. We got it. All right. Let's go ahead and on to the next one. So let's go ahead and let's zoom in here. So I want these defect reaction. So alpha is going to be plus 14, and TA is 5. Oxygen's there. Okay. Or incorporation of alpha 07 into into TA205. And let's do 3 more. Alpha 07, alpha 07, dash TA205, TA205. Right here. So, one must include an anion vacancy. So, vacancy and oxygen, 1, 2. Another must have a cation interstitial. So, alpha in the I, which is going to be, I'm going to cheat here. I'm going to do plus 14 because that's going to be tough to do. And then finally, a substitutional cation. So alpha where TA should be. So that's going to go from, that's going to be 5 to 14. So what is that? Plus 9? Yeah, that sounds good. All right, let's get this moving. So I am going to add, let's do this one first. So if I have a vacancy in my tantalum, that's going to be 1, 2, 3, 4, 5. So how can I make that negative? So I can do, yeah, I mean, that'd be a lot of those. Let's go ahead and let's bring it down over here. I have a plus 9 here. If I do another vacancy in tantalum, I'm off by that 1. So we're going to have to get some serious math going on here. But we can do it. So how about instead, let's do, so this is 5. So I'm going to go to 2 here, plus I'm going to do an oxygen interstitial, and that's going to be minus 2. So this will be 10, and then I'm going to do 2 of these. Good. So alpha, 2 oxygens here, plus 5 oxygen here, right? Oxygens, 7 of them. We're already charge balanced, which is good. 2 tantalums, and then 5 oxygens here. We're good. All right, that works. So let's utilize our oxygens. So I'm going to do, again, a vacancy in tantalum, 1, 2, 3, 4, 5, and then I'm going to do plus 2 oxygen interstitials, 1, 2 here, and I'm balanced, right? So 5 and 4, good. Alpha, this, plus 5 oxygen X. Tantalum, 2 tantalums, 5 oxygens. Got it. All right, last one. Vacancy in oxygen. I'm going to do an alpha interstitial, so that's going to lead me with plus 14. So I have 16 plus vacancy in tantalum. So I have, how many of that? Is that 16? Okay, I'm going to do 1, 2, 3, 4, 5. So I've got 16. So I'm going to do 2 of these plus oxygen interstitial. That's 10. So I'm going to need 1, 2, 3 of them. So let's count them up. I need alpha, so I need plus 4 oxygen X. So that means, let's do balance. Alpha, oxygen 3, 7, good. Let's go down. Tantalum 2, and then oxygen here 4, but oxygen there. Got it. All right, draw the Berger circuits for the planes. Let's get it. Actually, so let's do, I don't see any defect here, but I'm going to choose first tangent vector positive. I'm going to pick a starting point S. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right hand in that direction. Complete, no defect. What about here? Out of the board, I'm going to pick my starting point here. Start. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right hand, RH, start to finish. That's my burgers. Edge, because they're perpendicular. And then finally, I'm going to go out of the board here. So I'm going to go, this is going to be my starting point. 1, 2, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I need to finish. 1, 2. That's my finish. Start to finish. That's a left hand screw. And that's it. We will see you all in the next problem set.